Hi, hello. It's still here. Finally, last few months left, so I decided why not finish what we started in the first place. And here we are in this set of videos, me wearing the same shirt for all of the intros, and we're gonna start with an important skill that everybody needs to practice, and that is writing linear equations in two variables. In this video in particular, we're gonna be talking about the importance of substitution and the different techniques such as the properties of equality and transposition, which came from the previous thing that was mentioned. And that will be it. Let's jump right into it. Okay, let us start with writing linear equations in two variables. What we're going to discuss and focus on today are four different forms where we could start with. Basically, there will be different techniques that will be introduced, some familiar with, some are not familiar with. So the thing here is that we start with linear equations, putting them all in standard form, followed by putting them in slope-intercept form, and then by the help of substitution, we will put linear equations first in point-slope form because we will be given the point and a slope, and then afterwards we're gonna put it in slope-intercept, then we'll also try to put it in standard form. So it's a long process, but again, we're practicing the skills here of substitution and the properties of equality and or the technique of transposition, similar with what will happen later in the linear equation in two-point form. So with that being said, let us start with our first example with writing linear equations in two variables, putting it in standard form. So we have here the given y is equal to negative 4x plus 5. So what we're going to do here is to put it in standard form. The most important thing that you have to notice here is that the x variable and the y variable are both on the left side of the equation, while the c means the constant is on the right side. This is what I want you to understand first things first. You should know that there's two sides of an equation. What do we mean by that? The left side are the ones on the left of a certain symbol, and the ones on the right are the things on the right based on a certain symbol. And what symbol are we talking about? It's the equal sign. Do not make this complicated. Again, when we say standard form, there are two things that we are expecting to see on the left, and when it is again standard form, there's one thing that we are expecting to see on the right. So on the left, we want the x and the y variable terms to be there, and then on the right side, we want the constant only. So as you can notice with our given, only y is on the left side. We still have the negative 4x, the term including the variable x on the right side. So again, there are two ways that we could do this. The first solution that we're going to do is by properties of equality. By properties of equality, we're going to tap in our skills, whether addition property or subtraction property. So that's what we're going to do here. So let's start with this example by having y is equal to negative 4x plus 5. When we say properties of equality, since the term is equal, what we do on the left side, we also do on the right. Again, we know that our target is to have this negative 4x also on the left side. In order to do that, we have to think of the additive inverse of negative 4x. Since this is negative 4x, in order for that to be eliminated on the right side, we need to add 4x to both sides. And this is by what we call as the addition property of equality. Again, what you do on the left side, you do it also on the right side. By doing so, you will now have the 4x also on the left side, and since y is positive, this will be plus y equal to negative 4x plus 4x is equal to 0, so that will now be eliminated, and you will only have 5 left on the right side. So this is now in the form of ax plus by is equal to c. We did the addition property, and that's it. Again, the goal that we want to do is to put the x term and the y term on the left side of the equal sign, and then the constant on the right side. I would like to apologize if my pronunciation is horrible right now. I'm having allergy attacks. Anyway, so what is the other technique that you could do? you could also do what we call as transposition, where it is actually a technique that follows the properties of equality. Without the properties of equality, this technique will not exist. The reason why I'm showing a technique also on front of you, or for all of you, so that when you see teachers or professors that you will see in the future proceeding with a certain technique, you're not going to be lost. You know where it came from. That's the best thing that I can teach you. To teach you that, again, when you go in the outside world with other teachers, they have different techniques in teaching. And again, if they teach in one way only, you have to know what that way is. That's how important that is. So some teachers teach the properties of equality way, some teachers teach the transposition way. Some do both, and I do both. So choose your own poison, I guess. So what we're gonna do here again is the same thing. We want this negative 4x to be on the left side. So what you're gonna do is simple. You're gonna move it to the right side. Write it on the right side. But when that happens, it should become positive. You will still arrive with the same answer. So this is the note that I wish for everybody to take. When transposing or transferring, there are two words there. Sometimes I use transfer, sometimes I use transpose, but they're the same concept. So when transposing, the sign changes from, there are two things here that we could have. We could have from positive to negative, or from negative to positive. Again, once we do the transposition, as we move forward later, you will notice that again, once you move it, there's going to be a change, whether from positive to negative or from negative to positive. In this specific thing, we had the negative version and it became positive. The reason behind that is because the term that we transpose is negative in the first place. And as you can notice, it follows the same process. I mean, the same answer. Basically, the journey became different, but still got the same answer. And I would like to apologize if I keep reiterating this, but I have to make sure that you understand where transposition or transferring comes from. Again, it came from the properties of equality, mainly the addition or subtraction property. Okay, so let's proceed with our next example. Now this one is something that involves another property that we're going to use. So let's do again what we need to do just like earlier. The first type of solution that we're going to do is by properties of equality. So you don't have to make this complicated just yet. This one right here in particular has tons of different ways of solving, like different sequences, but it's your choice. What I would like to do here first is to put everything in whole numbers or whole integers. I don't want to see any fractions. So when you're dealing with something like this, since the standard form is not in particular in terms of the x and y variable, unlike the slope-intercept later, it's okay for the x and y variable here to have coefficients. So if you're going to deal with something like that, what you can do is apply a certain property of equality. Since there is a fraction, that means the operation there is division. You are dividing the 2 by 3. So it's 2 by 3 or 2 divided by 3 or 2 over 3. So what property of equality can we do here? Well, that's what we call as the multiplication property. We are going to multiply 3 to the entire equation. So this is by multiplication property. Again, I would like to reiterate the reason why I'm presenting this is because some teachers teach in a different way. I just want you guys to be ready with that. Some teachers teach in a way wherein the fractions are eliminated. They want everything to just be whole when it's in standard form in the first place. So what we can do here is multiply 3 to the entire thing. So distribute that. You'll have 3 times y, that will be 3y, equal to. So if you multiply 3 to 2/3, you will have 6 over 3x. Remember guys, when you're distributing a number to a fraction, you're multiplying that number to the numerator only. The next, you'll have 3 times -1, that will give you -3. So if you simplify this, you will now have 3y is equal to 6 divided by 3 is 2. So 2x minus 3. But we're not done yet. We're not going to apply what we did earlier. And that is by what now? Is it the addition property? No. We're now going to do the subtraction property of equality. Why are we doing the subtraction property? Because as you can notice, the 2x there is not negative, it is positive. So we're gonna do the opposite of that in order for us to eliminate it on that side and move it to the other side. So this is by subtraction property. So what we're gonna have now is negative 2x. Since 3y is positive plus 3y is equal to, the 3 is negative, so negative 3. So this is now the answer in standard form. And then the next thing that we're gonna do is by transposition, but again we're going to follow the same concept. In some cases, oh well, let's just show it. So in some cases what they do is they don't multiply it by 3 yet. Sometimes they do it in the middle. So that's what we're going to show, to be a bit different. So the same concept is what we're going to follow. We would like for the x term to be transferred to the other side. Since this 2/3 x is positive, when we move it, it will now become negative 2/3 x plus y equal to negative 1. And again, if you wish to eliminate the fraction, what you have to do now is to multiply the entire thing by 3. So this is what I'm talking about. It doesn't matter if you multiply the entire thing to eliminate the fraction in the beginning and the middle or at the end. It will still arrive with the same answer. This is what I'm trying to talk about. You'll have here 3 times negative 2, that will give you negative 6 over 3x. Then 3 times y, it's gonna give you 3y, and then multiply 3 to negative 1, you're gonna have negative 3. So when you simplify negative 6 over 3, that will give you negative 2x. Then this is plus 3y is equal to negative 3. So now it is in standard form. Now I would like to address something. I think I forgot to mention it earlier. Now, this is the most important thing that I want you to understand. The multiplication property that we're doing here is something that you should not be afraid of. We've done this, or you've seen this, when working on job word problems in rational algebraic expressions. Basically, what you're going to do, if you want to eliminate the fraction or the fractions in your given equation or inequality in the future, what you have to do is to identify the LCD. So the LCD here is 3 because there's only one fraction here, that's the 3, and the rest has denominator which is 1. So that's why it's just 3. So if you have two fractions, get the LCD, and that's the one that you're going to multiply to the entire thing. Okay? So it's similar to your job word problems back in the RAE universe. So this is your final answer. Again, it's the same thing as the first one. We will now move forward in writing linear equations in two variables, but this time around, we're going to put it in slope-intercept form. And this one in particular is something that I have mentioned earlier, that it is much more intricate compared to the first one. Earlier, we don't care if x or y has a visible written, what do you call this, numerical coefficient. Whether it has or none, we're good with that. Whether it's 1, a fraction, we don't care. But this one in particular, we can notice that the y variable must be alone on the left, and on the right, we should have two things. We should have the mx and the b. The m representing the slope, the b representing the y-intercept. So in here, in this case also, I'm sorry, but I have to go along with the explanation because we're going to relate these concepts in the future so that you already know how to identify it as we move for, or as we progress with the lessons. So by starting here, we have 3x minus 5y minus 2 is equal to 0. We could do it again in two different ways. Now here, when you do the properties of equality, it might be a little long, but it's okay. Again, the process is something that you guys might want to pay attention to. So we're always going to start with properties of equality for this video. Later, it will have substitution, so let's just be patient. So 3x minus 5y minus 2 is equal to 0. The thing that I would like for you guys to understand here, since we want it to be in slope-intercept form, our goal is to isolate the y variable. The reason why, again, we're isolating the y variable here is because we want it to be in slope-intercept form. Isolating the y variable, what we have to do first, identify the terms that are next to it. We have the 3x and then the negative 2. So we start by subtracting 3x to both sides of the equation. Let's call it SPE, subtraction, property of equality. Again, the reason behind this so that we could isolate the y variable. So we'll have 3x minus 3x, that's 0. So we'll have negative 5y minus 2 is equal to negative 3x. Next, we have here the negative 2 together with negative 5y. And again, the goal is for the y variable to be isolated on the left. So now what we're going to do is add 2 to both sides. This is by addition property of equality. Now, the reason why we're adding is because negative 2 is negative. To eliminate that, we should have a positive counterpart. Doing so, we will have negative 5y is equal to negative 3x plus 2. Here, we're going to apply a certain property again, and it is the division property of equality. Here, I've been telling you guys, since we have been applying this for a while, when doing division property of equality, you don't have to make it complicated. Simply look at the term, or sorry, by the coefficient, numerical coefficient next to y, and that will be the one that we're going to use to divide the entire equation with. Always remember, what you do on the left, you do on the right. So here, to eliminate the negative 5, we divide the entire thing by negative 5. Okay? The reason behind this again is we want the y variable to be alone. No numerical coefficient written. Again, it doesn't mean that there's no numerical coefficient. The numerical coefficient is equal to 1 because it's acceptable that we don't have to write it anymore. I just want to clarify that out. So negative 5 divided by negative 5, you'll get y here left. Negative 3x divided by negative 5. We can cancel out or simplify the negative symbol. So you'll have 3 over 5x. I would like to separate the x. I want you guys to get used to that because, again, the x variable and the 3 over 5 needs to be separated later in identification. I just want that to be the practice. Now, you have 2 divided by negative 5. You cannot do that unless you want to put it in decimals. So what I can suggest here is you simply put the negative sign above, minus 2 over 5. Because positive divided by negative is negative, and you cannot have a negative denominator. That's why just put it up or put it in the middle, just like the one that I've written in front of you. Now, in this case, do we have to multiply the entire thing by 5? The answer is no, because the goal is for the y to be alone. No numerical coefficient other than 1. Okay? So now, in here, we can identify 2 things. The letter m and the b. So in this case, we have our m, which is our slope, which is equal to 3 over 5. And then we have our b, which is our y-intercept, hence called the slope-intercept form. Our b is none other than negative 2 over 5. And the reason behind the identification process is for you to remember the importance of the slope-intercept form in graphing linear equations and in the future linear inequalities. So if you wish to do the other version by transposition, you can actually do it simultaneously if you want to. But for this video, I'm going to do it one by one so that nobody's going to get confused. So I can transfer the 3x to the other side. This will now become negative 5y minus 2 is equal to negative 3x. Why is it no longer 0 minus 3x? It's pretty much common sense that there's nothing on the right side but 0. So when you move something there, it's 0 minus 3x. 0 minus 3x is equal to negative 3x. So do not make it complicated for yourself. Negative 2, transfer that to the other side. You're going to have negative 5y is equal to negative 3x plus 2. And then by division property of equality, divide everything by negative 5. And voila, you're going to get the same answer. Y is equal to 3x over 5 or 3 over 5x. Again, I'm showing you the different ways you're going to look at it. And then negative 2 over 5. You're going to see something like that. The differences with writing, but it's still the same. The m is still 3 over 5. The b is still negative 2 over 5. And one thing that I would like to pay attention to, that I want you to remember, is that what does the y-intercept mean? What does it imply? Or what is one of its definitions or descriptions? We know that when we're getting the y-intercept, we have our x equal to 0. Hence, you can actually form an ordered pair given that you have the intercept, which is negative 2 over 5. Since this is your y-intercept, our ordered pair is none other than 0, negative 2 over 5. Sir, where did you get that? The ordered pair is again written as xy, and since we get the y-intercept when x is 0, automatically the x is equal to 0. So you write 0, and then the y-intercept, once after we write it in slope-intercept form, we got negative 2 over 5. So, excuse me, there we go. I'm so sorry. There we go. I'm sorry guys, I cannot edit way too much. I don't want to, rant or anything, but I have limited time. So let's go. Let's have another one. And we have here 4x minus 2y minus 10 is equal to 0. Don't worry. Some cases it's just, some cases it's just 2 steps. Some cases it's more. Again, the thing here is that I want you to get used to the properties of equality and or transposition, so that when you do these things, you're not gonna be limited. I want you to have, a lot of possible options. So when we continue here, you can have 4x minus 2y minus 10 equal to 0. We need to isolate the y variable, so we could start with subtracting 4x to both sides of the equation. So we will have negative 2y minus 10 is equal to negative 4x. Now we want the negative 10 to be eliminated, so we'll add 10 to both sides. Again, the explanation for the first one is subtraction property. What you do on the left, you do on the right. You subtract on the left, you subtract on the right. Same case with adding on the left, you add also on the right. That is APE. So again, the reason why we're doing these properties of equality in order for us to manipulate the equations from putting it in one form to another. Here we would like to isolate the y variable. So to continue, you'll have negative 2y because negative 10 plus 10 is 0. And on the right side, you'll have negative 4x plus 10. And again, the goal is to eliminate the numerical coefficient here because we just want y to be y. Divide both sides by whatever number that is next to y. Again, do not make it complicated. What's next to y here completely is negative 2. So divide both by negative 2. This is division property of equality. Doing so, you'll have y is equal to negative 4x divided by negative 2 is equal to positive 2x. Then 10 divided by negative 2, that will give you negative 5. So that is your answer. And I would like to repeat, we can identify the slope here as positive 2 or 2 over 1. The reason why I'm showing you already again the skills that we have discussed from the previous lessons is because it's going to be helpful for us in graphing in the future, putting whole numbers into their fraction form. Here, our b is none other than negative 5. Therefore, we can identify an ordered pair located at 0, negative 5. Again, because we get the y-intercept or the b when x is equal to 0. So, 0, negative 5. Similarly, if you wish to do transposition, we do the same process. Transpose 4x to the other side. You'll get negative 2y minus 10 is equal to negative 4x. Next, you can also transpose the negative 10 to the other side. You'll get negative 2y is equal to negative 4x plus 10. And then we divide the entire thing by negative 2 because we would like to isolate the variable. So you get y is equal to 2x minus 5. Same answer, different solutions. So that's how you write linear equations in two variables, starting with standard form and then this one in slope-intercept. So what we've done here are the properties of equality and the concept or the skill of transposition. This time around, we're gonna include another skill, and it's really important that you learn this properly. And this is what we call as substitution. So we're gonna apply our skills from the previous two concepts now with writing linear equations in two variables given a point and the slope. There is a formula here that is written. We have y minus y sub 1 is equal to m times the quantity x minus x sub 1. Now, In particular, just to give you guys a heads up, I'll be doing the properties of equality for all of the other examples for the rest of the video. Apologies, I cannot do both anymore because it will be time consuming. So if you want to try it on your own, you may check it out, pause this video, post the items, and then check if you manage to get the same answers, even if I did a different solution. Okay? So the first thing that you have to do here, the most important one, is to understand what these variable means. We use variables to represent certain values. They are labels. So what are the x values standing here for? How about the y values? So in particular here, we are going to substitute three different things: the -1, the 2, and the 5. So I want you to understand that when we're dealing with a point, we can label it as x sub 1 and y sub 1. Okay? So a point is represented by an ordered pair, right? Since this is the first point, we can say that this is x sub 1, y sub 1. Again, we got this in the pattern of ordered pairs where x comes first followed by y. The subscript, which we have mentioned before, implies which one is the first x, which one is the first y, based on the fact that this is the first point. So this means that we have -1 as our x sub 1, and then our +2 as our y sub 1, and the m is simply equal to 5. So this is the process of labeling them properly so that you will not be confused. Okay? Later kasi it's gonna be important to label it properly, like which one is your first point, which one is your second point. Doing so, we will now start with substitution. By substitution, we're gonna change the variables to the numbers corresponding to them. If you look at this given clearly, without overcomplicating it, we know that we don't have a value for y, so we just rewrite y. Then we subtract it 2. Now, in this case, we have a value for y sub 1, and that is your 2. So you change your y sub 1 to 2. Okay? Notice the difference. The y sub 1 now is 2 because that is the value that we're given with. That's how substitution works. Now, the letter m in the formula is equal to 5 in this given, so we write 5. Again, we change the m to 5 based on the given. Do not make it complicated. Next, we don't have a value for x, but we do have a value for x sub 1, and that is -1. We have to be careful here because the operation is subtraction and the value is negative. You may put it in a parenthesis first so that you will not be confused. So to continue, you will have y minus 2 is equal to 5 times the quantity x, negative times negative, that will give you +1. Okay? That's the reason why I decided to take my time before going to the next process. Again, if you're good at it already, if you know what's going on, you may skip some steps. But again, be careful because some of the best even make those small mistakes. There's this song like, even the best fall down sometimes, I guess. I think it's Collide. You might check it out. But anyway, let's continue here on the right side of the screen. Y minus 2 is equal to 5 times the quantity x plus 1. So what we did here is distribute the negative sign. Okay, that's what we did here. Now what we're gonna do here is distribute the 5. Sir, why are we distributing the 5? Because 5 is next to a binomial factor, or something that we call as a parenthesis. This implies multiplication, so multiply 5 to x, multiply 5 to y. So you have y minus 2 is equal to 5 times x, it's 5x. 5 times 1, that is equal to 5. And if you want to put this first in slope-intercept form, what we can do is to isolate the y variable. Let's add 2 to both sides. And as you can notice here, we have to put the constants in line so that you know what it's going to look like. So this is by APE. This will now become y is equal to 5x plus 7. So this is now in slope-intercept form, where our slope is equal to 5 again, and the y-intercept is something that we can find at 7 or 0.7 in particular. So if you wish to put this in standard form, all you have to do is to continue with your solution. You want the 5x also to be on the other side, so you subtract 5x to both sides. This is by subtraction property of equality. So you will now have your equation as negative 5x, since y is positive, plus y is equal to 0, then 7. That's it. So this is now in standard form. So again, in here, what we have done is apply the things that we have acquired from the previous two concepts, the standard form and the slope-intercept form. At the same time, what we're doing here is the process of substitution. So we have here our equation in slope-intercept, here our equation in standard form. Okay, so we're gonna continue now with our next example. Let's have the same thing, the same concept. So let's proceed with the formula. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. We know that again, this is our x sub 1, this is our y sub 1. Because the x comes first, followed by y. So we'll have y minus y sub 1, which is 2, is equal to m, which is equal to 9, multiplied to x minus our x sub 1, which is 2. Okay? So what we did here is by substitution. We change the variables to their corresponding numbers or values. Now what we're going to do is by distribution. Multiply 9 to x, multiply 9 to negative 2. So we're going to have y minus 2 equal to 9x minus 18. This is again by distribution or distributive property. So doing so, we can now add 2 to both sides of the equation. This is addition property of equality. The reason behind this is because you want the y to be isolated first. So you will have y is equal to 9x minus 16. This is now in slope-intercept form, and we can identify our slope as 9 and the y-intercept b as negative 16. Therefore, it is some point that we can locate at 0, negative 16, because we identify the y-intercept by having our x equal to 0. So to continue with this solution, we can have y is equal to 9x minus 16. To put this in standard form, let us subtract 9x to both sides. By subtraction property, we will have negative 9x plus y equal to negative 16. So that's it. It is now in standard form. That's how it works. I would like to apologize, the mic died, so we have to record this way. Now to continue, let us have our last set of examples. This time around, instead of having 1 point, we have 2 points instead. You might be wondering, what's the difference of this specific form to the previous one? The previous one is point slope. This one is 2-point form. As you can notice, the slight difference here is in line with the one that is gonna be distributed later. Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 is actually the formula for slope when there are 2 points given. So that's what we're gonna deal with now. To not make this complicated, you have 2 points being 2, negative 3, and negative 1, 2. We identify this as our first point, 2, negative 3, and negative 1, 2 as our second point. So what you have to do is to label it properly. So I will make the first point have x sub 1, y sub 1, the second point as x sub 2, y sub 2. Okay? So with that, let's continue with the formula. Y minus y sub 1 is equal to the quantity y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And then we're going to multiply that to x minus x sub 1. And then again, let's continue. Y minus negative 3 equal to y sub 2 minus y sub 1. That's going to be 2 minus negative 3. I know it's going to be long, but the process may be long, the journey may be long, but it's an important concept. Now let's start with x sub 2 being negative 1 minus 2. Then you're going to multiply that later to x minus x sub 1, which is 2. So that's it. So to continue with this, you have the negative sign and the negative 3. This will make it y plus 3 equal to. Similarly, you have the negative and the negative 3 here. That will make it 2 plus 3. Now we can we can simplify the -1 and -2 as -3. Then x minus 2. Ayan. Let's just double check if we're correct here. 2 minus -3 all over -1 minus 2. Okay, we're correct. Now to continue with this one, y plus 3 is equal to 5 over -3 times the quantity x minus 2. This could also be written as y plus 3 is equal to -5 over 3 multiplied to x minus 2. To continue, distribute the -5 over 3 to the entire thing. You'll have -5 over 3x. -2 times -5, that's going to give you positive 10 over 3. Now, the problem with this one that some may have a concern with is there are fractions here. So you have two options here, depending on the choices or if you're being asked to put it in slope-intercept or not. What we can do here is apply the skills that we have acquired earlier. Let's just say that I would like to put this first in standard form. So what I can do here is multiply the entire thing by 3 by multiplication property of equality. So we're going to have 3y plus 9 is equal to, let's just go with it, -5x plus 10. So the reason why I immediately went to -5x because -5 times 3 is -15 divided by 3, that's -5. Similarly, 10 times 3 is 30 divided by 3, that's going to give you 10. So when we continue with this one, let us subtract 9 to both sides. By subtraction property, you're going to get 3y is equal to -5x plus 1. Add 5x to both sides in order for us to put this in, again, standard form. So you're gonna have 5x plus 3y is equal to 1. So the reason behind the fact that I decided to simply go with having the answers without the fractions by putting it in standard form compared to earlier is because you can have the 3 to the other side, but you have to combine 10 over 3 and -3. That will be a little bit complicated, having a fraction and a whole number. So my suggestion is you may work with the multiplication property of equality in order to transform it in a much easier manner. So now it is in standard and it will no longer be difficult to put this in slope-intercept. You have to subtract 5x to both sides, divide the entire thing by 3, and you'll have your answer. So something like that. I guess that's something that you can continue. Again, the technique here is make it simple for you. Don't make it complicated all the time. And speaking of complicated, one last example. Let's deal with this. Let's have the given. We have 6, 2 and 2, 5. So let's label this as our first point, x sub 1, y sub 1. This is our second point, x sub 2, y sub 2. So using the formula again, y minus y sub 1 equal to the entire thing, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 times the quantity x minus x sub 1. And it's a bit long, but that's how it goes. So let's substitute y minus 2 equal to the quantity 5 minus 2 all over 2 minus 6. Yep, that's correct. 2 minus 6 times the quantity x minus 6. So if you continue with this, y minus 2 equal to 5 minus 2, that will be equal to 3. 2 minus 6, that's -4. Then x minus 6. Y minus 2 equal to -3 over 4 times x minus 6. The reason behind this, again, you cannot have a negative denominator, so bring it up. Distribute the -3 over 4, you're going to have y minus 2 is equal to -3 over 4x. Negative times negative, positive, so plus 18 over 4. You can simplify this later, but it will be much easier if we do the same thing as the technique that we did. Apply the multiplication property of equality. Doing so, what we're gonna do now is multiply the entire thing by 4. And you will have 4y, 4 times y, 4 times negative 2, negative 8. 4 times negative 3 over 4 is negative 12 over 4. So we're gonna have negative 3x. 4 times 18, that will give you 72 over 4 divided by 4. So you're gonna simplify it as 18. And that's it. And then now we're gonna do is add 8 to both sides first. So you're gonna have 4y left, negative 3x plus 26. Then add 3x to both sides so that you can have it in standard form. You will have 3x plus 4y is equal to 26. So now it is in standard. And again, you may put this in slope-intercept form. So let's show that. So you may start by, starting with this now. If you want it to be slope-intercept form. So you have the 4y already equal to negative 3x plus 26. The only thing that you have to do here is divide the entire thing by 4. Doing so, your slope-intercept form will be simply y is equal to negative 3 over 4x plus 26 over 4. That's it. So again, the standard and then the slope-intercept. I hope in this video you managed to learn how to substitute, how to use the properties of equality, and the importance of substitution. Apologies that it got long. I just have to dive in deep with these examples. But again, just like always, you may skip some concepts if you already get it. That's it for this one. And that ends our video lesson for today. Please take note of all the skills, the techniques, and all of the details that you need to master in order for you to understand these concepts clearly. Some of these lessons you don't have to really memorize everything, but you just have to embody the skills, master it, practice it, and then with that, everything's gonna work well. And in case you don't see me, always remember, good morning, good afternoon, good evening, and good night. Peace out. Respect.